Okay, this is in preparation of your iodine clock lab. I'm going to go over some things and get you prepared for as we go into that lab this week. So this image is kind of the general setup of what we're doing. Basically, we're going to put solution A and solution B together, and we're going to time how long it takes for the solution to appear blue-black. Okay. So part one, I'm just doing a demonstration, but I'm actually we go over the demonstration, and I'm actually going to let y'all do the lab. And there's some different variables we're going to change up with the lab as we go through it. So we're going to use demonstration data to talk about some things in preparation of it. So here I have different concentrations of 0.1 molar KiO3, and we look to see how the reaction time has changed as we do this. So this is showing you, this is our time here, and one of the things it asks you to do is to calculate the concentration of KiO3 in the solution. And so the way that you're going to do that is you're going to do M1V1 equals M2V2. And so I simply take my 0.10, which is my concentration or molarity, and then I'm going to take my volume in liters. Okay, that's equal to the M2, and then the total volume in liters. And you solve for your M2. And so I've done this on all of these, and I've left my math here so you can look at it to check your understanding of that. Okay, so the next part I have some questions, and I'm already going to have my answers up there for you. So one of the questions is, as the concentration of KiO3 changes, what happens to the reaction time? So we can see that we went from 0.25 to 0.05. And this one all of a sudden is 0.0125. So we had to rank these. We had to rank these in concentrations. Right? This is my weakest. This is my second weakest. This is my third strongest. Or this is my weakest, middle, and strongest. And what we should notice is if we look at our times, when my concentration is low, it takes me longer to get to the change. When my concentration is higher, it's much quicker. So as the concentration of the KiO3 increased, the time increased. The reaction time increased, sorry. All right, it's the reaction time. How is reaction time related to reaction rate? The reaction time is inversely related to the reaction rate. All right. Then, what is the relationship between the reaction time and the rate of reaction? The rate of reaction increases as the concentration of the reactant increases. So that's a direct relationship. Part 2. Why was the total volume of solution A kept constant during the iodine clock demonstration? So if we're interested in looking at one part of the reaction, then we need to make sure we only have that one thing changing. So we're going to hold everything else as a control. Okay? And hopefully you recognize that. So if we're holding the solution A, if we're holding one of them to be constant, and we're changing the other one, the change has to be coming from the one that we're changing in the solution. So then ask, why was the concentration of solution B kept constant? Well, again, if we're looking to try to figure out what the dependency of time was, we're going to hold one constant to see what the effect of the other one was. And so we're able to prove that the change in concentration in the KiO3 is altering the reactive time. Okay, so your lab. There's several sections to your lab, right? I'm going to have solution A, solution B. You need to measure out these amounts, okay? You're going to have your test tubes lined up. Make sure you label them, and you're going to have to time them. You're going to have to agree on when it changes to that color, all right? So on part 1, we're going to increase the amount of solution A and see what happens when we do it. Part 2, we're going to increase the amount of solution B and record what happens to it. So you can see we're holding solution A constant, changing B. Then on part 3, we're going to dilute A, right? And we're going to hold solution B constant. So what happens when we dilute? Does that have an impact on the time? Then on part 4, we're going to flip that, and we're going to hold solution A at a constant 1 milliliter, and we're going to dilute solution B and see what happens to our time. Then we're going to end by changing the temperature. So you're going to do a cold water bath, and you're going to do a hot water bath, and you're going to time how long it takes, and we'll see what happens. And then you have all this analysis due, okay? Now, for the graphs, what I would recommend is do a manual graph in Vernier. Then take those and put them into your report, okay? And then the rest of these, you have to use your data to try to figure out what's going to happen. It does have you on some of these. It's going to ask you, well, what would happen if we did 6 milliliters of it? What would you predict? Okay? Use your data to help you answer these questions. Okay? And that is it. That is your introduction to the Iodine Clock Lab. Live long and prosper.